Good morning. So we're going to be taking notes on mean absolute deviation, or what we like to call MAD. This is a way for us to compare data when we have a data spread using the information that we already know, mean, median, and mode. At the end of this conversation or topic, we should be able to find take the mean and be able to find the average distance from the data value to the mean. This is how to compare the spread of data. The standard is 6SP5. And by the end of this topic, once again, you should be able to summarize numerical spread sets or data sets by giving the mean, absolute deviation. And deviation is just a word that we use in math to talk about the distance. So the first thing we need is to have our definition for mean absolute deviation. And that definition is mean absolute deviation, or MAD, refers to how much data how much the data varies from the mean. And that even itself sounds a little confusing. So what I like to say is, and I'm going to put a little asterisk or a little star, is that it's the average distance between each data value and the mean. So now let's talk about how do we find it. So that's our definition. But let's put it into practice, and I think then the definition is going to make even more sense to you. So how to find it. First thing that you have to do is when we get our data set, we're going to first find the mean. And remember, we find the mean by taking all of the data and pieces of data that we have, adding them together, and then dividing by the number of data pieces that we have. So then, once you've done that, now how much does each point differ from the mean? And what this means is you're going to take the mean and you're going to subtract the value from it. And when you do that, so you're going to take each piece of data and subtract it from the mean, and that'll tell you that this number of the distance, kind of like absolute value. When we have absolute value, remember you take 0 and you just count how many hops you take to get to 0. It's the same concept, but in this case, the mean would be that place of 0, and you're going to count how many hops it is to the mean. Once you do that, you're going to add all the differences together and find the mean of them. So once you've now figured out all of the differences, then you add those all up and then divide by what you have there. So that's the steps. Now let's put them into practice. And this is where it really becomes like, oh, okay, this makes sense. It sounds more confusing than really what you're going to find it is. If you can find the mean, you'll be able to find the MAD, the mean absolute deviation, because it's the same process. It's just going to be a second step. So here's the data that we're looking at. I'm going to make this a little bit bigger. And on this data set, we have 2, 2, 3, 3, 4, 5, 5. The first thing we're going to do is we're going to find the mean. When I add up those numbers together, 2 plus 2 plus 3, 3, 4, 5, and 5. I know that 2 and 2 together make 4, 3 and 3 make 6, 4 and 6 make 10, 5 and 5 is 10, and I like to cross these off. So I've done those, I've done those, I've done those, and I'm left with this 4, 4, and I end up with 24. Let me double check that I did that right. 2 plus 2 is 4. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 10 is 20, 24. So now I have 24. I'm going to divide that 24 by the amount of numbers I have. 1, 2, 3, 4, 5, 6, 7. So 24 divided by 7. So we know that it goes 3 times, which is 3 remainder. I'm going to have to add my 0. This is 4, 28, 2, and then 2. And I'm going to stop there, actually, rather than keep going forever. I'm just going to, once I get to that second digit, we can stop. So my mean is 3.42. Now that I have the mean, I'm going to go to the next step, which, how much does each one differ from the mean? Okay, so going up here, I'm going to say, okay, I've got 2, 2, 3, 3, 4, 5, and 5. How much does each of those numbers differ from the 3.42? Well, to figure this out, I'm going to kind of create a table of sorts. To figure this out, you take the mean, which is in this case 3.42, and subtract the number in our data set. So subtract 2. So each of these, I'm going to be doing kind of the same problem because they're the same. Well, if I take 3.42 and I subtract 2, what do I get? What would my answer be? Cody?
1.42.
1.42. Okay. Now I'm going to take the mean and I'm going to subtract 3. Well, what is 3.42 minus 3? Cody, again.
0.42.
0.42 or just 42, right?
Mm-hmm.
And this one's the same. Now, here's where it gets a little confusing. On the next set, you're going to have a 4. Now, what we've been doing is taking the mean and subtracting the data number from it. But in this case, when your data number is bigger than the mean, you flip it. And so instead of doing 3.42 minus 4, I'm going to do 4 minus 3.42. So I would do 4 minus 3.42. Now, for sake of time, I'm going to use a calculator for this one, but you could actually do it long ways. 4 minus 3.42, I end up with 0.58. Okay. You can tell me what I do with the 5. You want to give it a shot? What do I do with the 5, James?
You do the exact same thing you did with the 4.
So it would be, what would my problem be?
5 minus 3.42.
Good. So I'm going to use my calculator again. Remember, you don't have to use a calculator. You just put your little 0 placeholders in, and you can do this as well. So 5 minus 3.42 equals 1.58. And the last one is exactly the same. Are you guys following me? Okay. So now that we've done this, we've created this new data table with the distance for each value from the mean. Now what we're going to do is we're going to add up all those together. So I'm going to add, and on this I'm adding the differences. So I'm going to add 1.42 plus 1.42. I'm adding these numbers plus 1.42 plus 1.42 plus 0.42 plus 0.42 plus 0.58 plus 1.58 plus 1.58, and I get 7.4. 0.42 when I've added them all up. So I added all these numbers together and I got this. But I need to find the mean of that, the average. What do I do next? To find the mean of a set of numbers, what do I do, James?
You divide that number by how much data?
Which we had 1, 2, 3, 4, 5, 6, 7. So I'm going to divide 7.42 by 7, and I get 1.06. This is what we call the MAD, or basically the average distance each of these numbers is from 0. Sorry, I said 0. I meant to say the mean. So if I were to have a number line, I would count the average distance going back to the mean would be about 1.06. So now, when you get to 119, which is the one before, you're going to do the exact same process. Using your notes, I would like you to start filling in the blank on the data in the practice. It does talk about the steps. Make sure you're following all of the steps. Thank you very much. Go back and watch the video if needed.